Greetings, 6th grade students and parents. This is Mr. Korn. Today we're learning about area and perimeter of shapes in the coordinate plane. We previously talked about graphing points in the coordinate plane, finding distances between points in the coordinate plane, and the students have also learned how to graph points and connect the dots to make shapes in the coordinate plane. But now when we do make shapes, we're going to talk about how to find two important parameters of the shapes, which is area and perimeter. First, in order to find the area and perimeter of shapes in a coordinate plane, we first must understand what the area and perimeter are. This is from a website called mathisfun.com, a very helpful website for all math topics of all grades. The area, first of all, represents the amount of space inside a two-dimensional shape. So, for instance, if this were a floor, the area would represent how much carpet is needed to put on the floor. If this represented a sandbox, it would talk about the area would represent how much sand is needed to fill the entire rectangle. So the area is the amount of space inside a shape. So first, in order to find the area, you must apply the area formula. The area formula is width times height. We also can say base times height instead of width. So some textbooks and some math problems you'll see saying the term base instead of width. In this rectangle, first you must find the width, which is how wide it is, also called the base if you're talking about the bottom of the shape. And the width, or the base, is 5 in this example. Then you got to figure out the height. The height in this example is 3. So in order to find the area, which is how much space on the inside of this 2D shape, you must take the width times the height, 5 times 3, and you'll get the area of 15. Now, when it's on a grid, such as a coordinate plane, the student can actually count the amount of squares on the inside, and you can find that there actually are 15 squares on the inside. And you can get that 15 again by height times width, or base times height. Either way, 3 times 5, or 5 times 3. And you'll get the area of 15. And this works, of course, because you have 3 rows of 5 or 5 columns of 3, all equaling 15. The next, of course, is the perimeter, and the perimeter is different than area. Whereas the area represented the space inside the shape, the perimeter represents the distance around the outside of the shape. Perimeter can be thought of as walking around a track, for some context, or building a fence around a yard. Okay? What is the total distance around? And the perimeter, you simply add all the sides of the shape together. In this shape, it's a rectangle, you'd be adding 4 numbers, the 7, the 3, a 7 again, and another 3. The perimeter of this shape would be 20. When you find the rectangle has the same height, the same distance on the top and the bottom, and then of course the same distance value on each side, you can actually change this formula, and rather than add all around, you can say 2 times 7 or plus 2 times 3. Okay? And I'll give you the same perimeter as adding them all together. Okay? So once again, area represents the amount of space inside a shape, and you get that by multiplying the height times the width. And the perimeter represents the total distance all the way around the shape. So you simply add all the side lengths together. So now let's talk about how to find the area and perimeter of shapes in the coordinate plane. So here's our coordinate plane. Oops, sorry about that. Here's your coordinate plane. It's got your x-axis side to side, your y-axis up and down, and here are some points. So sometimes I will ask the student to take these points and find me the area and the perimeter of the shape that it makes. So this incorporates multiple skills. First, the student will have to plot each point on the coordinate plane to find the shape. So we'll have to go through our steps. First the side-to-side x count, then the up and down y count. So as a quick review, you start in the middle. Our point we're going to do first is -1, +1. So I must move first side to side, -1. Then I must go up or down, and it was a +1 for my y, so I have to move up in this case. And my first point is here. Then I must plot the second point, -5 on the x, +1 on the y. Start in the middle, -5, +1. You'll notice that these 2 points are in line with each other. They have the same y value, +1. So even though they are side to side, different spots than each other, they are lined up on the y-axis. Let's look at the next 2 points. -1, +5. -1, +5. Back 1, up 5. And then lastly, we will have -5, +5. So we go back 5, up 5, and there we have our shape. And if you connect the dots, you'll see that we have a nice 4-sided shape. Now, you and I can possibly tell that this is a square, but for students, they might not be able to tell by first glance. So the way to tell exactly if this is a square or a rectangle is by counting the distance between the points. So this side length on the bottom here, which is our base or our width, is 1, 2, 3, 4 units. If this is 4, we know, because of the properties of squares and rectangles, this has to be 4. And then we must count the height. 1, 2, 3, 4. It ends up that it's also 4. And of course, if that's 4, this side has to also be 4. In this problem, it's just we can say 4 units or 4 squares. But other problems will tell you that each square is equal to a mile, or maybe each square is equal to a block, or a foot, or an inch. In that case, we would add the unit of feet, or inches, or miles after the number. But in this case, we can just say units, because the problem doesn't tell us what each square is worth. So we know that this shape is a square because there's 4 on each side. The distance of 4 on the base, distance of 4 on the height, distance of 4, distance of 4. So now let's find our area. How many squares are on the inside? Well, we can of course count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, which is a very acceptable method, but for some large shapes, and for shapes where we don't have a grid, it's impossible to count, or very hard to count. So we just use our area formula. Area is equal to base times height. And in this case, our base is 4, and our height happens to also be 4. So we do the simple calculation of 4 times 4, which is equal to 16. So we can say that our area is 16 square units. Next, we can look at the perimeter. What is the perimeter of this square that we just made? Well, the perimeter is the distance all the way around the total distance. So we must add all the side lengths together. And I tell the students to picture that they're starting at one point and walking all the way around. And they have to find the total distance that they walked. How far did they walk? Well, they walked 4 units here, plus another 4, plus another 4, plus another 4. So we just add all the side lengths together. There's 4 sides to a square, so we're adding 4 numbers. And coincidentally, just by pure chance, this happens to be 4s as well as the distances. So we add 4 plus 4 plus 4 plus 4, and we get our perimeter of 16 units. In this example, the area and the perimeter matched because the side lengths were all the same. However, not every example will there be a matching area and a perimeter. But, once again, the first step is to plot your points. Carefully plot them on the graph. Then, find the distance by counting the distance between each point, and label your shape as such. Then the next step is to simply follow the formulas. For area, the formula is base times height. In this case, 4 times 4. And the perimeter is simply the total distance all the way around the shape. In this case, 4 plus 4 plus another 4 plus another 4. All right, if you have any questions, feel free to reach out to me. Have a great rest of your day, and I'll talk to you next time. Bye-bye.